Hey team, welcome back to my channel. As you can see, I'm using the website mycompiler.io. Here I can just type in a full-blown C program, compile it, get it to run, and it doesn't really make me install any software locally. Let's begin. We're going to be looking at two-dimensional arrays in C programming. Notice I've included stdio, standard io.h. Now we're going to say int main, open curly, close curly, and the last line of our program is return 0. Now how do we declare a two-dimensional array? Well, what we can say is int matrix, and then we do some brackets. We're going to do two sets of them, and our first one is going to be 3, and our last one is going to be 4. Now, what does 3, 4 mean? Well, let's think about this for just a second. The 3 equals rows, and the 4 equal columns. If I were to show you a Microsoft Excel spreadsheet, notice that we have 3 rows and 4 columns. So this would be considered a 3 by 4. Now there are several ways that we can initialize this matrix with data. Look at this first pattern. I'm going to give 1, 2, 3. That's the 3, that's the rows. And each one of these sets of data has 4 elements. 1, 2, 3, 4. So 3 by 4, that's what that looks like. You have to admit, that's pretty easy looking, right? And, let's proceed. Now, if we don't like this format and we want to make it look a little different, let me show you what that would look like. Here you can clearly see which index for the row and column that we're using, and I have populated it with the same data. So pick which method you like best and then just stick with it. Now let's learn how to loop over this two-dimensional array. So we're going to use a for loop. Now it all begins with for int row equals 0, row is less than 3, and then r row plus plus. Well, that's how we loop over the row. That will give us this row, and this row. Now we want to look at the elements. So we'll call that column. Say for int col is 0, col is less than 4, and col plus plus. Does that make sense? Well, now that we have our 2 loops to loop through that, all we have to do now is print that to the screen. You can see here I have finished up the print statement. So %d, %t, I'm going to print the row, the column, and then the matrix for the row column, right? That gives us a value. That makes sense? And notice the output. So we have 0, 0, I have 10, 0, 1, 20. So you can see how I'm going across. That would be 0, 0, that would be 0, 1, 0, 2, 0, 3. Down at the bottom, we have 2, 0, 2, 1, 2, 2, and 2, 3. I think you get it. Now, of course, this is one way to load the matrix array with data and then show the contents. Let me show you another way to do that. I'm going to remove this and let's continue. Now what we're going to be doing is using pointers. So we can say int star head. And what will that equal? Well, that will equal the address of the matrix 0, 0. And then we can put one at the end, int star tail equals the matrix. And what would I use there? Well, you got it. I want to use this position. That position is 2, 3. You can see that right here. So I'll come over here and say row 2, 3. Excellent. And now what we can do is we can actually print those to the screen so we can actually see the memory location for this computer. Now notice I'm saying here the start location equals placeholder with a P. Now P is where I get the memory address. And notice I'm going to pass head in to this placeholder. Then we're going to be using tail, and that's the end location. Let's go ahead and run this and see what happens. So here you can see our 2 memory addresses for the head and tail. Now let's just use these pointers and then loop through this two-dimensional array and print all the values. So how can we do that? Well, we can say while the head is less than equal to the tail. Now we're talking about the memory addresses there. And then we're going to say printf. Let me see. First I want to show you the memory address, and then I want to show you the value, a new line. And then what are we going to put there? Well, we're going to say head. And what is going to be second? Well, we want to get the value of that position. So we say star head. I think you get it. So this head goes into %p, this placeholder, and then the value is %d. So the first time around, I should print 10. Now, how do we move the head pointer to the next element? All we have to do is say head ++. That increments it for us. And remember, I'm starting with this memory address, and notice the next memory address is only going to be the size of an integer. So every 4 bytes is where the next integer is at. But all we have to do is say the data type is an int pointer, and we're going to take the memory address ++. So let's go ahead and do this, and then let's run it. There you have it. You can see that we started with FO, right? And then every 4 bytes, you see that? And even when we're going down to the next array, it's still only 4 bytes, right? Does that make sense to you? So it just stays on the line, and just, every 4 bytes, I'll be able to initialize that array. So it looks like just a two-dimensional array is a one-dimensional array with offsets. That's the way I always think about it. Now, I've been doing this for a long time, so that's just the way I think. Of course, it's easier to think two-dimensional, and I know that this right here would be 2, 0. I know that. So let's do one other thing, and sometimes I don't want to mess around with my pointer locations. I want to use offsets. Let's see one other technique. So let's begin with another pointer, say int pointer. And where are we going to set that to? We're going to set that to the address of matrix 00, right? To the very beginning. It's going to be pointing at this individual element here. And then we're going to print that individual element. So we'll say printf, and then what prints the address? %p. What prints the value? %d. Let's set up the printf function. We will use 2 placeholders, %p and %d. We will use pointer to use the first placeholder and star pointer to get the value for the second placeholder. Now this is where it gets a little tricky. So if pointer points here initially at 00, how could I make pointer point at 20? You got it. All we have to do is increment the pointer. So if I come over here and say pointer ++, well, guess what? When I print this again, it's going to actually print 10 on this one and 20 on this one. Let's see that. So here you can see 10 and 20. Now let's think for a moment. You saw that this one right here will print 10. How can we print this last one, 1140? Well, think about this for a minute. If this is 0, remember when I said ++? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I say pointer + equal 11, well, that will now be pointing at this address. Let's run this. Now over here in the output, we should get 10 and 1140. You're getting it. And guess what, team? That's all I have with the introductory to a two-dimensional array. I hope you were able to learn a thing or two. I'll see you back in my next video. Take care.